We're going to talk about data storage and data access in Dataproc. When migrating your Hadoop or Spark jobs to Dataproc, your jobs get migrated to the cluster itself, and the data should usually get stored in cloud storage. To connect your data in cloud storage with the Dataproc cluster, you would use the cloud storage connector. The connector allows your jobs running on Dataproc to read and write directly from cloud storage, and this avoids the need to replicate the data in HDFS or any other file system within the cluster, although sometimes that will be necessary, as we will discuss. Let's break down the benefits of using cloud storage in your migration strategy. First, HDFS compatibility. When moving data from Hadoop, you don't need to worry about complicated transfers. Cloud storage makes that simple because you can just use the GS prefix instead of the HDFS prefix. This streamlines access and makes it easy to continue your workflows. Next, interoperability. One of the major advantages of cloud storage is how seamlessly it works with other services. Whether you're using Spark, Hadoop, other GCP services, storing your data in cloud storage ensures that everything communicates smoothly, promoting a more integrated and efficient system. And then there's data accessibility. With traditional HDFS, you would lose access to your data if you shut down a Hadoop cluster. However, with cloud storage, your data remains accessible even when the cluster is offline, providing flexibility and uninterrupted data access. High data availability is another crucial point. With cloud storage, your data is highly available, and multi-region replication can ensure that it's globally replicated without any performance loss. This guarantees that your data is both secure and accessible for multiple locations. And finally, in contrast with HDFS, there's no storage management overhead with cloud storage. Unlike HDFS, which requires ongoing maintenance, such as checking the file system or upgrading versions, cloud storage handles all of this for you. So you don't have to worry about routine maintenance tasks. GCP takes care of them, and this allows you to focus on more important things. While the cloud storage connector is an excellent choice for most use cases, there are specific scenarios where you might want to stick with HDFS on Dataproc. First, if your application demands extremely low latency data access, HDFS might be the better option. This is for scenarios where even the smallest delay in fetching data, due to factors like network latency, can impact performance. Since HDFS stores data locally on the same cluster where processing happens, it eliminates the need to go over a network, and that ensures data retrieval is as immediate as possible. Second, if you require local storage for faster processing, HDFS allows you to store data directly on the cluster nodes. This is particularly useful when working with large volumes of data, and storing data locally minimizes the time required to transfer data from a remote storage system, such as cloud storage, to the cluster before processing can even begin. So this speeds up computation. Although these two might seem like they're solving the same problem, it's important to note that one is about eliminating network delays for fast retrieval, while the other focuses on minimizing transfer delays for large data sets before computation even starts. Both contribute to faster processing, but they address different aspects of data access and retrieval. Lastly, you may need to use advanced HDFS-specific features like fine-grained replication policies or other specialized configurations that cloud storage does not support. These HDFS features are occasionally required in complex environments where a high-level control is needed over how data is stored and replicated across nodes. And that's when you would use HDFS as well. In addition to working with data in cloud storage or on HDFS, you can work with data in BigQuery from Dataproc. GCP offers 3 specialized connectors. First, the Spark BigQuery connector allows Spark jobs running in Dataproc to directly interact with BigQuery tables, which is particularly useful for things like Spark ML jobs where you need to read and write data to BigQuery during processing. Next, the Hive BigQuery connector provides a storage handler allowing Hive to use its familiar HiveQL syntax to interact with BigQuery tables. This can be useful for those who prefer Hive for querying large datasets. Lastly, the Hadoop BigQuery connector simplifies Hadoop jobs by allowing mappers and reducers to work with BigQuery data. It does this by abstracting the input format and output format classes, enabling seamless interaction between Hadoop and BigQuery. You should strongly consider using these connectors, especially if you already have datasets in BigQuery or are looking to migrate data directly to BigQuery, like if you want to do that with Impala data, for example. Now this slide shows the two ways to connect Dataproc to Bigtable. First, we have the HBase client. This involves connecting your Dataproc cluster to Bigtable through an HBase interface. You can use the HBase shell in your terminal or the HBase client APIs. Here you interact with your Bigtable instance using these familiar HBase commands. This is a straightforward method if you're already working with HBase or you need low-level access to tables and data. Second, we have the Bigtable Spark connector. This option enables Dataproc's Spark jobs to interact directly with Cloud Bigtable. You can leverage Spark's powerful distributed processing capabilities, combining it with Bigtable scalability. This approach is ideal for large-scale data processing tasks, such as running Spark ML jobs on top of the Bigtable data. That's something that could show up on the exam. And in both methods, you're enabling Dataproc clusters to efficiently work with Bigtable, depending on the type of access and integration your workflow needs. So those are the options. You should strongly consider these connectors if you already have datasets in Bigtable or you are looking to migrate data directly to Bigtable, like with HBase data. Let's go over an example exam question. So you're planning to move on-prem Hive data to Dataproc on Google Cloud. While the Hive files have already been uploaded to a cloud storage bucket, some of the data also needs to be stored in Dataproc's HDFS. What are two methods you can use within Dataproc to achieve this? Now, before I reveal the answer, think about the key concepts that we've already covered. And we've talked a lot about how Dataproc can seamlessly integrate with cloud storage, but we also talked about how that's not the only way to mount data for Dataproc to use. So here are two ways that you can solve this problem. First, you can use the cloud storage connector to access the Hive tables from cloud storage, define them as external Hive tables and replicate them to HDFS. This takes full advantage of the cloud storage connector that we discussed earlier. The connector allows you to interact with the data in cloud storage directly without needing to transfer it to HDFS first. And so then by defining the Hive tables as external, you keep the data in its original location, cloud storage, while also replicating it to HDFS for jobs that require it. This approach is flexible and it leverages the best of cloud native and traditional HDFS storage systems, which we've talked about at length as well. Then the second option, you can move the Hive data to the cluster's master node, copy it into HDFS using the Hadoop utility and mount it from HDFS. This is more direct. Here you're manually moving the Hive data into the master node of the Dataproc cluster, copying it into HDFS and then mounting it. It's more aligned with HDFS specific processing, which we covered when we talked about scenarios where in-cluster storage and low latency data can be more important. If you need faster access to data or specific HDFS features, this would be potentially the better option. So in essence, this question ties together two key themes from our course: leveraging cloud native storage like cloud storage for flexibility, and using HDFS when you need the performance benefits of that local storage. Understanding when and how to use both gives you the flexibility to handle a wide range of scenarios, including some that you could be asked about on the exam. So when you are asked questions like this, remember that it's about choosing the right strategy for your job's needs, depending on whether you need to keep data in storage, in cloud storage for flexibility, or bring it into HDFS for faster in-cluster access. That's it on data storage and access with Dataproc.